Oh yeah, senior night. We have two. Two. All right, 11. Read me 11. Thank you, Cortland. 11.
Okay, the capital F of t equals the natural log, and it's division, and the top part is, in parentheses, 2 plus 1, or 2t plus 1 to the third over 3t minus 1 to the fourth.
Like this?
Yeah.
Yeah. So, if we're just trying to use that Lin rule, isn't this a nightmare? Can you really, realistically, do you want to take the derivative of this?
No.
Using quotient rule and chain rule and then simplify that thing? So this is the only place I have ever seen where we needed to possess this knowledge. Why do we need to be able to separate Lins? Because the directions say expand it. I mean, this is the only place I've ever seen where I really had to use that concept. So if I separate this thing and make them all single Lins, then it's a whole lot easier to take the derivative of each part. So let's expand this. Instead of having it as one single logarithm,
So it'd be like 3 ln of 2t plus 1 minus,
minus
4 ln 3t minus 1.
sure, I'm not going to do it quite that fast,
So just leave the.
but I'm going there. Hang on. I'm
Okay.
just doing this to make sure. Couldn't I rewrite it like that? Because it's a division argument, so I can write it as 2 Lins subtracted, and now I can take those exponents and move them out front. So 3 times ln of 2t plus 1 minus 4 times ln of 3t minus 1. Now, isn't this very easy to take the derivative of?
Yes.
Yes, not like that. That's nightmarish. Isn't this very easy to take the derivative of? So remember, when you're taking the derivative of a function, when it has a coefficient out front, it's just going to be 3 times whatever that derivative is. So the derivative would be 3 times. Now, what would be the derivative of ln of 2t plus 1? 2 over 2t plus 1. And that was simple. Subtract 4 times 3 over 3t minus 1. So this could be 6 over 2t plus 1 minus 12 over 3t minus 1. If we needed to combine this into one fraction, should we be able to? What would the common denominator be? Don't FOIL it out. Just leave it as factored. Yeah, you wouldn't need to FOIL that out. You can just leave it as 2 factors like that. So that would mean the numerator here is missing the 3t minus 1. So would that be 18t minus 6? And here it's missing 2t plus 1 minus, make sure you realize that's a negative. So negative 24t minus 12. So then negative 6t minus 18. Is that right? Did I combine those terms like correctly? Okay. How far did the book take it? Good answer.
They took it on your first answer.
They stopped here?
Yeah.
Okay, all right. So AP Board, again, will accept it either way, but if it's multiple choice and they take it this far, then you have to. Okay, so I'm good with either one of those answers. So we have number 13. Somebody help me out with number 13.
Number 13, you said?
Yes, sir.
G of x is equal to ln of a minus x over a plus x.
A minus x over a plus x.
Yes.
Okay, from this notation, what is supposed to be our independent variable?
X.
Ooh, yeah, x. This is telling us the independent variable is x. So what is a?
Constant.
A is representing a constant, correct. So you're supposed to be looking at a as a number and x as our variable. But I don't even want to use quotient rule to take the derivative of that. I prefer to go ahead and separate it into 2 different lns. So we would change this into ln of a minus x minus ln of a plus x. Now when we take the derivatives, it's going to be a whole lot easier to differentiate. What is the derivative of a minus x? Negative 1. And then over that same u value, which is a minus x. Minus 1 over a plus x. Could you find a common denominator and combine those fractions if necessary? I hope so. All right, let's look at number 15.
Ln of u over 1 plus ln of 2u.
Okay, start again. I'm sorry. Ln of u.
Over 1 plus, it's like on top.
All of this is my numerator.
Yeah, that's it. And then over 1 plus ln of 2u.
Like this.
Yeah.
Okay. All right. So here, can I separate those?
Wait, no, you can't.
This is not all in one single logarithm.
Yeah.
So this one can't be separated.
Quotient rule.
So I'm going to have to use quotient rule. But aren't these simple arguments to work with? Okay, so we're going to use quotient rule. What do they call this function? What was the letter for it? F or F?
U.
Okay.
That's what it is.
It is what it is. So f of u is our function, and to take the derivative, we're going to need to use the quotient rule. So our denominator, 1 plus ln of 2u, times the derivative of the numerator. What is the derivative of the numerator? It'd be 1 over u. Minus, now we keep the numerator the same, and multiply by the derivative of the denominator. What would be the derivative of the denominator?
Just 2 over 2u.
2 over 2u. So I can just change that to 1 over u. All over the denominator squared. So now let's distribute that 1 over u in our numerator, combine like terms, and we'll be done. So I have 1 over u plus 1 over u ln of 2u minus 1 over u times ln of u all over this squared. Could you factor out a 1 over u from everything? Sure. How far did the answer key take this? Okay. All right. Oh, I see. I got it. Okay, so the answer key takes it a little farther, so let's make sure that you can simplify this. I could factor out a 1 over u from everything, correct? Perhaps. This will be a 1. You're going to have a ln of 2u here. What can you do with ln of 2u? How can you separate that? Wouldn't it be ln of 2 plus ln of u?
Oh, yeah. Okay.
And now haven't you factored out this 1 over u? Which would mean you're left with minus ln of u. What happens to those ln of u's?
Cancel out.
They cancel out. This is all over that denominator squared. So then our simplified answer would have to be, since this says 1 over u, couldn't I leave the 1 in the numerator and put the u in the denominator? So we're going to go with 1 plus ln of 2 over u times that denominator squared. Taylor, am I right now?
Yeah.
Okay. All right, Phaedra.